so lesson 45 is on integrals of inverse trig functions. So we've talked about the derivatives of things like inverse sine of x, inverse tangent of x. You guys memorized inverse sine and inverse tangent, correct? Remember our derivatives drill? So going backwards, so we know that the derivative of inverse sine is 1 over the square root of 1 minus x squared. So if I'm integrating 1 over the square root of 1 minus x squared, surprise, it becomes inverse sine, okay? So the two that you need to know are the inverse sine and inverse tangent. To my knowledge, I have not seen anything else besides those on the AP exam. My students have told me it's only inverse sine and inverse tangent as well, but who knows, maybe they're lying to me. So those are the ones you need to know. Would it be hard to memorize these other ones? Oh, yeah. Like inverse sine, inverse cosine. See how they're related. How are inverse sine and inverse cosine related? It's just a negative. I think you can handle that. How about inverse tangent and inverse cotangent? Right, just a negative. So you should already really know inverse sine, cosine, tangent, and cotangent. You got 4 of them. You just put a negative. What about inverse secant and cosecant? Could you probably memorize one more? You probably could, just in case. Because you never know, the AP test, I feel like it's harder every single year, and they put different things on there, and this is one of the things that it says could be tested, right? So, might as well. All right, so anyway, so it says you will often have to adjust the integrals using U substitutions to get it in one of the above forms. All right, so looking at number 1, our traditional U substitution method doesn't really work. So what I mean by that is what we've been talking about so far is things like under a square root is what we would typically make our U, right? So if I did this, so don't write this, but kind of watch. If I let my U be 1 minus 4x squared, then my du then would be negative 8x dx. And this causes a problem because I'd have my negative 1/8 du equals x dx. But what is wrong with this integral? There is no x. That x dx, there's no x. I can't replace it with that negative 1/8 du. Do we understand? So we have a problem. We don't have that x. So when that happens, think about those two that I told you to memorize, inverse sine and inverse tangent. This one, we want to get like one of those integrals. So we want something like 1 over, do you think it's the inverse sine or the inverse tangent? Probably inverse sine because it has the square root, right? So we want it to look like this, 1 minus u squared. That's our goal. If I'm trying to get it in the form of the square root of 1 minus u squared, what am I letting my u equal? To what? 2x. Does everybody see that? Because that is 1 minus, in parentheses, 2x squared. Do you see it? This is 1 minus 2x in parentheses squared, like that. That's what we have there. So that's why we're letting our u be 2x. All right, now when we do our du, that's nicer for us because now we get 2 dx. So I have 1/2 du, which is going to replace our dx. So as I'm replacing, I have the integral. I have my my dx was replaced by 1/2 du. And my square root part is now the square root of 1 minus u squared, like I want. So I have 1 over the square root of 1 minus u squared du. Now, since this is a definite integral, right, we have our 0 to 1/2. We can change those numbers as well. So my u of 1/2 and my u of 0. When I plug in 1/2 to my u function, u equals 2x, I get 2x times 1/2 is 1. When I plug in 0, 2 times 0 is 0. So I'm going to go from 0 to 1. You stuck? Let me integrate. So when I integrate the 1 over the square root of 1 minus u squared, we end up getting inverse sine. So it's going to be inverse sine of x, or of u, sorry. Go ahead. It's okay. Going from 0 to 1. So we get 1/2. Why would I do what?
What was all that business with the u of 1/2 and the u of 0? Wouldn't you just replace the u with
2x.
U equals?
You could. Like you could integrate it and then with the u and then change it back to x's. You could always do that. We did that before. whatever you want to do. All right, so now here's the hard part. I know you guys are all going to be pros because every single one of you, I think, had me for pre-calc. Isn't this exciting? Yes. So either summer pre-calc or during the year. So when you see something like inverse sine of 1, I have confidence in you. I know that you know what that means. But maybe a quick refresher just in case. Maybe? All right, so inverse sine of 1. What this means is the sine of some angle is equal to 1. And that angle is restricted from negative pi over 2 to pi over 2. It's on the right side of the unit circle. So we're saying what angle gives you a value of 1? What angle would that be? Pi over 2, exactly. So we get 1/2. We're going to have pi over 2 for that first one. So this next one is saying, what angle on the right side of the unit circle gives me a sine value of 0? Yeah, 0. So we wouldn't say pi, we would just say 0. So that next one's going to be minus 0. So our answer is 1/2 of pi over 2, which is pi over 4. Yeah, if you remember when we talked about the graph for sine, it's not what we call 1-to-1. So when you find inverse functions, like if you have f of x and you're trying to find f inverse of x, we needed it to be 1-to-1. So it needs to pass the horizontal line test. So an inverse function flips over the line y equals x. It becomes like a reflection of it, right? And so if the original function is 1-to-1, then the new one passes, instead of the horizontal line test, it passes the vertical line test. So it becomes a function. Otherwise, it's not a function. So if we wanted to pass the horizontal line test for sine, we restrict it from here to here. So every horizontal line that goes through, right? If you think about it in the unit circle method, we say, well, what side of the circle will give me every single y value on the unit circle? Because we're talking about sine, right? So every y value is from here to here on the unit circle. We don't need to do this side because then those values repeat if you do that side.
So it's restricted, like, as in that's the only side that you use?
Yeah.
Okay.
Yeah, and if you use your calculator does only give you one answer. It's because it's a certain function, like we have a function. It's like when you solve for a function like y equals x squared, and I get its inverse. It's the square root of x, but also the negative square root of x. Those are two functions put together. We want it to be a one function at the end. All right, so that was way more detailed than you probably wanted, but we'll move on. All right, so number 2. So we have the integral of x over x to the 4th plus 9. So if you tried your normal u substitution, you were like, I'm just going to make it the denominator. I'm going to make it x to the 4th plus 9. Do you see how that might be a problem? Because then our du would involve 4x cubed. But this one doesn't involve an x cubed. If that had been an x cubed up there, you're good to go. You can integrate it. But it's not an x cubed, it's just x. See the issue? So that's when you think about your two different formulas. So does this one look most like inverse sine, which involves a square root, or inverse tangent, which doesn't? Inverse tangent, surprise, surprise. So we want to get it in the form 1 over 1 plus u squared. Or you can say 1 over u squared plus 1 if you want. Okay, this one's going to take some moving around, some fixing. The big problem that we have is we don't have a 1. Do you see how it's plus 1 on the bottom? U squared plus 1, or 1 plus u squared. Right, we have a 9. That's going to make it a little tricky. I think you guys can handle it. We'll see. So here's what we're going to do. So we want a 1 here. So we're going to take our x to the 4th plus 9, and we're going to factor out a 9. So instead of having x to the 4th plus 1, what am I going to have in that first spot? Yeah, x to the 4th divided by 9. So I'm dividing each thing by 9. Right? Then I can pull this 9 out here. Is it just a 9 in front, though? It's a 1/9, right? Because it's on the denominator. So now we have x over x to the 4th plus 9, or x to the 4th over 9 plus 1. So there's a point to all of this. I know it looks strange right now.
Oh, did you pull the 9 out?
I pulled it all the way to the front,
Okay,
yep.
I thought you were multiplying. I was like, what is happening?
All right, so I have my 1 over 9 and my x, and I want to identify what is being squared plus 1. So I have x to the 4th over 9. Basically take the square root of it. You get x squared over 3, right? That is what we make our u. So I know it's a little bit weird. So we're letting our u be x squared over 3, which you can write as 1/3 x squared, really, right? So then our du is going to be 1/3 times 2x, so it's going to be 2/3 x dx. So in other words, we have 3 over 2 du is equal to x dx. And look, magic, we have x dx right there. That's what we wanted. You see how the substitution is going to work for us? So we get 1/9. My x dx is replaced by 3 over 2. Let me put that 3 over 2 in here too. So it's replaced by 3 over 2 du. Then I have a 1 over u squared plus 1. So I get 3 over 18, which is 1 over 6. And then the integral of 1 over u squared plus 1. Inverse tangent of u plus c. So our final answer is 1/6 inverse tangent of u was x squared over 3 plus c. And then we're done.
And how did you know it was inverse tangent?
Because remember our derivatives drills, when I gave you like y equals inverse tangent of x, you memorized that its derivative is 1 over 1 plus x squared. So we're going backwards. We have the integral of this creates this. Okay. All right. Let's try it more like that because they're a little weird when you first see them. All right, so next one, we're trying to get it in the form 1 over 1 minus x squared. So we want 1 over 1 minus, well, square root of 1 minus u squared du. That's what we want. So again, this is not a 1. We need a 1. And that's sometimes the hardest part, like trying to manipulate it so that that becomes a 1. Okay, so what we're going to do is under that square root, I'm going to still pull out a 4, but it's still under the square root. And if you don't like the dx on the front top, you can always put dx on the side if that bothers you. All right, so when I pull out a 4, I get the 1 that I want, and my x squared becomes x squared over 4. Does everybody understand that? Just dividing each piece by 4. Someone in the last class was asking about this next rule. Do you guys remember like in Algebra 2 when we talked about like 25 times 4? You could multiply it and get 100 and then take the square root. Or you can take the square root of each piece. Oh, I don't know why I did that. Not square root of 5. You can take the square root of each piece, square root of 25 and square root of 4, and say, oh, it's going to be 5 times 2, which is 10. Right? You guys remember that rule? That's what we're doing here. So we're going to break up the square root. So I'm going to have the square root of 4, and I'm going to have the square root of 1 minus x squared over 4. And that square root of 4 is going to go on the outside as what number? 1/2. You see it because it's on the denominator, so 1 over. Now we have this, and we need to identify x squared over 4. What is being squared to get that x squared over 4? X over 2, right? That's going to be the u. So we're letting u be x over 2. So du, please don't do quotient rule. So many people try to do quotient rule on this. It kills me. This is 1/2 x, right? So its derivative is 1/2 dx. It's like 1/3, 1/2 dx. So we actually do have the 1/2 dx here. But if you didn't recognize that, you can do the thing we talked about with the 2 du equals dx, like multiply the 2 over and then replace. So you're like, okay, I got the 1/2, and then my 1 dx is replaced by 2 du, and then I have 1 over the square root of 1 minus u squared. So basically these go away. So when we integrate, we get the inverse sine of u plus c. So our answer is inverse sine of x over 2 plus c. That makes sense? All right, so I want you guys to try this next one. You need a 1 here. So that's your first step. You got to try to get that to be a 1. So try it. Oops. So we need that to be a 1, so we're going to pull out that 4. So when you do, you're going to have 1 plus 9 over 4x squared on the bottom. So that 1/4 can go all the way to the front of the integration sign. So I get 1 over 1 plus something squared, and that something is usually your u. Right, that's the whole point of this. So what am I going to put inside the parentheses there? Exactly, 3 over 2x. So we're letting our u equal 3 over 2x. So then our du then is going to be 3 over 2 dx. So if we want to get dx by itself, we have 2/3 du equals dx. You basically take the square root of it. Yeah. So now we get 1 over 4, the integral of 1 over 1 plus u squared. And then our dx is replaced with 2/3 du. So I'm going to put a du, and I'm going to sneak a 2/3 in there. See? I know. I have the magic tool that lets me just erase that right away, but if you're writing in pen, I'm sorry. All right, so I get 2 over 12, so that's 1/6. And then if I integrate, I get inverse tangent of u plus c. So our final answer should be 1/6 inverse tangent of 3 over 2x plus c. And you can always do the derivative using the chain rule, right, to see if you go back to the original. All right.
Why would it be tan
If it's subtracting, what do you mean? Did I say minus?
Like when you said the square root of 4 minus x squared, is that height of which one it's from?
Basically, if there's a square root, it's going to be your inverse sine. If there's not a square root, it's going to be your tangent, probably. Right. All right. Last two. Are we ready?
Oh no, it's getting worse.
It's not getting worse. You got this. So the next one with the sine and cosines is actually, it's almost there. Because we at least have the 1. Yay, there's a 1. All right, Michaela, what do you think? We would make the cosine equal to u. Is everybody else there too, or is Michaela just ahead of the game here? She's got it. Just the cosine is u.
Okay, cosine x though.
Cosine of
I
x.
thought
Oh.
you just meant, like cosine. I was like, I don't think that's good.
No, that's right. I am very particular about putting cosine of x and not just cosine, right? All right, so then our du is negative sine of x dx, which is lucky for us because we have sine of x dx in the problem. So this part's being replaced by the 1 plus u squared on the bottom. And then the sine of x dx is being replaced with our negative du. So when we do this, we get 1 over 1 plus u squared. And then the sine x dx was replaced with negative, so negative out front, and then du. So this one's a definite integral, so we have numbers. So we need to find u of pi over 2, and we also need to find u of 0. So we have cosine of pi over 2. Do we know that right away? Cosine of pi over 2 is 0. Good, unit circle. Cosine of 0 is 1. So I get, instead of 0 to pi over 2, I have 1 to 0. You can, which is kind of nice because you had a negative before as well, right? So when we flip it, we get rid of that negative as well. I'm so proud that you guys know your unit circle, by the way, because I tutor so many students from Cathedral, Park Tutor, Rebuff, and they don't use the unit circle, and it drives me bonkers. So when you say something like sine of x equals root 3 over 2, like you guys in your head can say the two values on the unit circle where sine of whatever angle, so what angle gives you a sine value of root 3 over 2, and you know that it's 60 degrees, or pi over 3, and 120 degrees, which is 2 pi over 3. And you know that without drawing anything. You can just do it in your head, correct?
If we have it memorized.
Totally. And you know what they do? They draw this. They draw, and they're like opposite over hypotenuse. And then they say that that's 1, and then they're like, oh, so my 30, 60, 90 triangle, so that's going to be 60 degrees. And then they think about 60 degrees and, oh, it's painful. So you guys are good.
You print them out like the circle. And
I make them memorize it. I'm like, please just do this for me. All right, so anyway, so we have inverse tangent of u, and we're going from 0 to 1. So it's going to be inverse tangent of 1 minus inverse tangent of 0. And I admit inverse tangent is the trickiest of the inverse sine, inverse cosine, inverse tangent. We're still doing the right side of the unit circle.
Wouldn't they be flipped? So it would be.
No, because I did the negative thing and I flipped them.
But U was at the 0 was at the bottom, so that means the 1
when you plug it in,
So you plug this in and plug that.
I am so confused.
All right, so inverse tangent is on the right side of the unit circle, just like inverse sine. Do you guys remember where cosine is? Cosine is up here from 0 to pi. So cosine's the weird one. So
Also, what
tangent.
happened to the negative in front of
That's what I did, Julia. I flipped them and made it negative. All right, so inverse tangent of 1. So what I'm saying is tangent of some angle is equal to 1. Exactly. So it's basically saying sine over cosine is equal to 1. So Emerson is already saying pi over 4, it's pi over 4. I agree. This next one, Alex, seriously,
What are you doing?
is saying tangent of theta is equal to 0. So sine over cosine is equal to 0. So basically where sine is equal to 0, which is 0. I agree. So our answer is pi over 4. All right. I bet Michaela has this one too. Do you know this one? That's it. Pi over 4. Done.
Well, I mean,
E to the what?
Oh.
U equals what?
E to the X.
E to the x. That is e to the x. Yes, because if you have e to the x and you square it, you get e to the 2x. So what we have under there, this is 1 minus e to the x squared. So our u is e to the x. Yep. So our du then is going to be e to the x dx, which is nice because that was right here. So when we replace, we get 1 over the square root of 1 minus u squared du. So Julia's ahead of the game. She said inverse sine of u plus c is going to become inverse sine of e to the x plus c. Done.
Can you actually solve for that though? Like if you have it.
Like sine of what angle gives you e to the x? Leave it like that.
Choose your battle.
Yeah, well, you have like more, like you have an x and you have a theta, right? I'd write it like that. All right, that's it. How do you feel about it? We'll see. You have some time to work on your homework, so we'll see.